Hey everyone, my name is Vaibhav Shah. I'm a senior solutions architect here with Amazon Web Services, and I've been here over 2.5 years. So my focus is on dealing with customers, helping customers build solutions on cloud. And I'm based out of Boston, so I mostly in my enterprise space, I help customers in enterprise and financial services. But even outside of that, when it comes to especially serverless, I hop on to help any customers that's needed. Now, just so that it's easier for me to sort of toss around with the screens, I'll quickly stop my video. Just wanted to introduce myself over here, and I'll quickly move on to the agenda. So, high level of agenda is I'll be covering some overview of serverless services on AWS. My keen interest here is to share some of the popular architecture patterns and use cases that you can build for your own enterprises as well. I have packed a lot and I'll try not to go 20 over marks, but apologies if I do. And I'll quickly go over the first two slides because it just gives overview on AWS and on serverless. And my keen interest is to highlight architecture patterns and spend more time on those use cases as well. So just to have a high level overview, right? Most of the innovation today, if you look at the developers' time, is they spend on operations and maintenance, right? And in the future, the goal here is that the developer time must be more utilized towards writing the business logic, to writing the code that generates business for the organization. Now, this is why serverless adoption is growing so fast within our customers, because a serverless strategy, it enables them to focus on things that benefit their customers and not spend most of the time in infrastructure management. Now, the 4 key areas I want to highlight here that we are always innovating and trying to provide those in a very simple and yet powerful capabilities is providing our customers with serverless the agility to move and develop faster and also improve performance, to support as many workloads as possible. So the innovation shouldn't be restrictive over here just because you might need to provision servers and so on. And that's where serverless is more powerful, where you can quickly come up with, spend time more on business logic and quickly come up with a code and just deploy it in one of our many services that we have. And I think one of the key factors is also the cost. It helps keep the cost low for the applications you are running on serverless. And the reason that is because you just only pay for what you're using. So basically, if you have low traffic application, low invocations and low execution time, you exactly only pay for that much period rather than having your servers run like 24/7 of the time. And also it provides built-in security because security is job zero here at AWS. So we always make sure that in serverless services and managed services, we have security built in and we always continuously improving upon it. There are also factors and knobs that we give you control over because it's a shared responsibility model where you have flexibility to change and configure security on top of what we already provide. Now, when I work with customers, we have seen this pattern that they adopt while they're moving or going serverless. They often start out with a low-hanging fruit and simple tasks like IT automation, such as using Lambda functions to validate some configuration, each time an EC2 instance is launched. Or maybe some kind of daily batch operation that you might want to trigger and have Lambda function do that job for you. Next is data processing level. Individual teams might, once they see the power of Lambda functions and serverless services, they start integrating it with storage services like S3 or with streaming services like Amazon Kinesis to build the data processing applications. And then as and when the experience spreads within the teams, what we see is that people and developers and architects, they start building a whole microservice-based application, which are often used for web and mobile applications using Lambda functions and other services, serverless services that comes along with it. And then finally, I think the epitome would be where where customers start using Lambda function, machine learning applications as well, and start leveraging the power of it. Now, one thing is common across any serverless application is that they follow the design ideas of internet and web. So where small and loosely coupled services are sort of come together and work in a very well choreographed manner. Now, all of these applications are sort of modular. They're composed from multiple AWS services and customer developed components on top of it. That's why we are focused on delivering a lot of integrations and let's say between Lambda function, event bridge, which acts as an event router, API gateway, which is nothing but a front door to your applications, and then step functions as well. So we want to make it easy for you to build those applications and add functionality to it through loosely coupling this components. It often starts with an API. API gateway is all like API gateway is a managed service for AWS, which helps you manage your APIs, create and deploy APIs. It basically acts as an application front door in most of the cases. And often events or messages in the communication system, in the backend and all are coordinated with the workflows. Serverless is just more than Lambda function. So you see there are multiple, these are core components on which the serverless, we provide those serverless services. For example, in compute, you have AWS Lambda, but also you have AWS Fargate, which is the serverless manner of running containers. In data stores, we offer S3, where you can store your files, documents, and so on. Then we have Amazon Aurora. There's also a serverless version for that, which is nothing but a SQL-based database, and Amazon DynamoDB, which is a NoSQL-based database. And then finally, moving on to some integrations. Now, these are loosely coupled services and that you can use to join your application to application or application to database. So this is where all the events are basically they're triggered or they're stored, so that all of the compute can pick it up and start processing it. So we will cover the services like on a high level as we go along. I hope most of you know what Lambda function is, but I just wanted to use this one slide to give you an overview. It's basically an event-driven function as a service. Now, a function is nothing but a unit that we use for the Lambda service itself. And a function run is called an invocation. So function invocation can handle like a single event. Now, on the left-hand side of the architecture, you can see event source. So whenever there's a change in data, change in the data state, or there's a new API invocation or change in the resource, it can in the backend trigger or invoke a Lambda function, which can then do some kind of processing on the languages mentioned here. It supports Node.js, Python, Java, C#, most of the popular languages. After that processing is done, you can store the output and any database that might fit the use case or any storage service like S3 and so on. So we will cover this, once we look into the use cases as well. Now, this is where I want to spend much of my time over here talking about serverless architecture patterns. I want to talk about various architecture patterns that you can build your applications using this serverless components. Before that, starting with very basic event. What is event in general? So services that are triggered by events that occur in the infrastructure. So event can be any change in state. For example, an order was placed on your website. A ticket was created, a support ticket was created on your website. So all these things is nothing but a change in the state, which we call as event. And we use events to trigger and communicate between decoupled services. Now, thus far we have looked at APIs. I'll talk about API-driven architectures. So these are nothing but synchronous requests where client calls an API and it waits for the response. Now, in the serverless world, each API request is in fact an event. That event describes a request. Example, it can be HTTP, it can be REST method, it can be a GraphQL query string parameter, and so on. So every invocation, can be considered as an event. Now, Lambda function itself supports 3 different types of invocation. Synchronous invocation, which we are just talking about, which is nothing but API invoking the backend service, a client waiting for a response, and the response should be fairly quick, ideally under 30 seconds. And that's what we term as what we call as synchronous invocations or synchronous processing. Asynchronous on high level is something like a fire and forget model, where client will, let's say, send an event and wouldn't expect a response. The job is only to send event. In that case, it can be used for batch processing, and there are multiple use cases for that as well. Pool-based in general is something that where the consumer pulls the messages from the source event, right? So from the sources that's generating that event. So the source does not need to invoke. All it does is a consumer that's basically approaches the client or the source and pulls the events or messages out of it. So basically, just high level, 3 type of invocations on Lambda: synchronous, asynchronous, and pool-based. Now, in event-driven architectures, which is a second kind of more, and it's gaining popularity a lot. So event-driven architectures are mostly asynchronous in nature. It can be incredibly powerful for dealing with, let's say, large-scale processes and disparate systems. Now, because here the client is not waiting for any response, we can also process events as the resources become available or in batches. So, for example, you might have a consumer, and the consumer might not always be won't be that highly available. If you have a lot of stream of events that can come in and the consumer becomes overwhelmed, asynchronous plays a very vital role here, where you basically give flexibility of the consumer to process those events as and when the resources are freed up. Now, as we move on, we'll look at 4 different services that is available on AWS that allow for asynchronous processing of events to happen. Now, each provides different advantages for different types of workloads, and you can use that in conjunction to each other, or one over each or the other, depending on your use case. And each of them is built to be highly resilient, scalable, and provides a very high flexibility as well. So rationalizing your serverless architecture, it basically requires that you think about event sources and how serverless functions can be activated or invoked or trigger. Events are asynchronous, so you don't need to wait for a response, as we discussed, to move on to the next step. But this improves the resiliency and reduces the overall dependencies of your architecture. And the tools of event-driven architectures are basically routers that abstract producers and consumers from each other. So now you can publish an event or a message to the router, or the consumer without the knowledge of the other producer or consumer can consume it. Even such event routers in AWS, we have a service called Amazon Event Bridge and Amazon SNS. These 2 services acts as event router. We can also call it like a pub sub model. And then we have something called event store, which acts as a buffer, and it holds on to that events until the consumer is ready to use them. So at AWS, we call it SQS. It's our serverless event store, or queue. And we also have something called Amazon MQ, which is another queue. And it is, it uses standard APIs and protocols. It's managed version of the open source version of MQ. So if you have running, if you have MQ, RabbitMQ, ActiveMQ running on-prem, and you're looking to sort of, migrate it to AWS and make it more serverless, Amazon MQ is the place where you look at. Now, these are the 4 key services that make serverless that event-driven, that it's that what we call it now. So it allows for this asynchronous processing of events. Each provides very different advantages. And starting with Amazon SQS, right? It's a fully managed queuing service. It enables you to decouple and scale microservices, distributed systems, and any serverless application. So any publisher can, push messages to SQS. SQS will store it. You can configure for how long it can be stored and so on. And whenever the consumer is ready, can pull the message from SQS and starts processing it. So it basically acts as a decoupler and acts as a buffer between two components of your architecture. Amazon SNS, moving on, is a fully managed messaging service for both system to system as well as application to person communication. So it enables you to communicate between systems through PubSub or publish subscribe model. It enables messaging between decoupled microservice application or communicate directly to end user via SMS, mobile push, email, and so on. So it's something, if you just want to, like an announcement, like an application, let's say an order is placed in an application, and that information needs to be passed on to multiple consumers to fulfill, to let everyone know in an independent fashion that, hey, this new order was placed, so now you do your job. So one end, the publisher will publish it, and on the consumer end, subscribers, whoever is listening to that message, will pick that message and start doing their task. One task can be of fulfillment, fulfill that order for me, and then people and the warehouse start working on that order. Once they get that notification, so the application will get it, and so on. The second can be payment processing. Third can be analytics. Just want to see what orders are coming in and study the patterns of how your consumers, what they're buying, and so on. So applications can be plugged in and plugged out anytime you want using SNS, and that's the beauty of it. Moving on is Event Bridge. It's a serverless event bus that makes it easy to connect applications together using data from your own applications. So integrated SaaS applications, AWS services, and so on. Event Bridge delivers like a stream of real-time data from event sources, like such as Zendesk, Datadog, PagerDuty, and it routes that data to targets like AWS Lambda and many other services it supports within AWS. So you can set up routing rules to determine where to send your data to build application architectures that react in real time to your data source. So this does not act as an event store, but it acts as an event bus. Show the event and pass on that event to the target that it should receive. Last but not the least is Step Function. It's again a serverless function orchestrator. Now this is more like if you want to do orchestration, want to develop your components using a workflow kind of architecture, like sequence of Lambda functions and other multiple services that can be, there's a bit business critical. You can sort of create a workflow to it. So through its visual interface, it does provide a visual interface. You can create and run a series of checkpointed and event-driven workflows that maintain the application state. So the output of one step over here will act as an input to the next. So each step in your application, it executes an order and passes on the output to the next, to the next step, which acts as an input to that state. And it can be flexible depending on what kind of business logic you define here. Now, that's on a high level about various architecture patterns. Now, I want to cover use cases, like where and when can you use search services and, sort of give a thought where it can fit into your work and into your projects. Now, starting with a very simple RESTful microservice, API gateway here acts as a front door for your application to access the data or business logic or any functionality from your backend services. Now, using API gateway, you can create RESTful APIs, HTTP APIs, WebSocket APIs that enable real-time two-way communication. Right? API gateway, if you remember, like it expects like a client request and response model. A simple example here would be a user registration portal. A user opens a mobile web app, registers itself to your website, invokes the API gateway, and in the backend, API passes on that request simply to AWS Lambda, where it processes your application, or takes your name, email, contact information, whatever that you provide, processes it, and let's say stores in DynamoDB, which acts as a database over here. So it can be used like a simple user registration portal is one of the examples. In the same example, you can, maybe want to also add some observability component to this architecture. This is where CloudWatch and X-Ray comes into picture, where, if the invocation fails or if the Lambda fails to process a request, this is where CloudWatch will basically track every invocation, see if there are any errors happening. AWS X-Ray gives you like an end-to-end application flow, or the request flow to your architecture. It gives you visibility into that. So you can add an observability component here as well. Another example of API-driven, I would say, is AppSync. It's again a completely managed graph. Now, this is a GraphQL and PubSub API service. It allows you to power your application with the right data from one or more data sources on a very global scale. It simplifies application development as well by letting you create like a flexible API to securely access or manipulate or even combine data from one or even many data sources that can be either databases or maybe other APIs, as you can see on the right-hand side of the architecture. For example, AppSync APIs can access data directly on DynamoDB NoSQL tables, or Aurora serverless databases, or even OpenSearch clusters. By the way, there's a serverless version of that as well. And applications can access anything in your account using Lambda functions, even REST APIs, with the HTTP resolvers. Now, you can easily have both REST and GraphQL in your behind an AppSync API. It would just depend on what kind of use case you are dealing with. You can use HTTP resolvers to connect directly to AWS services, Step Functions, Event Bridge, or via other regional endpoints, which means it can be used as a GraphQL facade to any AWS service. So it's also possible to use any local resolvers if you want, and think of it as a PubSub channel, but only for APIs where data is not persisted. It's just basically passed along. Now time to dive into a little bit of event-driven use cases. For example, right, this is like processing any file uploads that you have been doing. So let's say you are owning or running an application which uploads a document and basically stores it somewhere. And that somewhere can be Amazon S3. And that's one part of your architecture where you are storing or uploading a document. Now, the next step is, what do you do with that document? So as soon as, you can make this event-driven as well. As soon as a new file or new object is uploaded to your bucket over here, with that, you can invoke a Lambda function. Like, hey, a new object or new file just got uploaded. So let's do some processing over here. Now, for example, it can be anything. For example, you're verifying an identity of a user. So you're asking them to upload their license copy. They upload it. It gets uploaded here. You use Lambda function to process the information or that's coming in that license, right? So it can be fit into your application. Now, if you want to make it more, more business critical and more use case driven, you might also want to check, like, is it a legit license or is it, as a fake one or something? So you can do further processing. You can leverage AI ML services like Amazon Recognition, which identifies the photo of the person who has uploaded it and see if it's, like how much original that is by different scores it comes along with. You can also store the metadata, which is related to the document, in this case, license, to your database using DynamoDB. So it can be name, license number, and so on. So you can store such information along with AI ML capabilities, which can identify if the license is original or not. You can also make this as a workflow by making, if you add a step function layer over here, once the object is uploaded or document is uploaded, you can, this Lambda function can invoke a step function or a workflow where you first identify is the document real or not, extract some information, and then maybe store it. If it's not valid, maybe fail the process and so on. So this is where the workflow adds value to your architecture. Another popular use case is streaming of data. So any real-time data, any live game you're live streaming that you're watching, any analytics, let's say you have a call center and you have calls coming constantly and you want to see those events, you want to see or analyze those events. So this is where Kinesis Stream comes into the picture, where it constantly, it's not a single invocation, it's constantly streaming data over here. And Lambda function basically keeps on polling those messages, those events, keeps on processing it, and then maybe, storing it somewhere in a bucket, or maybe putting it in your Redshift cluster, which acts as a data warehouse. You can use it somewhere else, like Kinesis Data Analytics, to analyze the events that are coming almost real time using dashboards. So there's a lot of power and a lot of use cases, apart from real-time streaming, real-time analyzing of call center events and so on. Many use cases that you can leverage this architecture. You can also make it like a sort of semi-serverless webhook, where in a similar architecture, you add like an API component to it. So basically, you are making like a web application, maybe making an initial API request, and then just simply passing on those events to Kinesis, and then Lambda function basically processing at a later time, or at a time as and when the events come in. Fan out is another very popular way of architecting solutions on serverless. So very classic example, for example, in e-commerce website, through your web portal, if you're opening Amazon.com, placing an order, the Eventbridge says, oh, okay, an order is being placed, a new order has been created. So maybe you want to let that know to your fulfillment center application. If it's been processed or if it's been returned, based on the status message that comes along with the order placed, you can pass it to different applications, maybe multiple applications. Once it's created, you want to do fulfillment applications, start working on it. You might want let billing application know, like, okay, process this. You might want to add an analytics layer on top of it. So you can add and remove as and when with your convenience, and with different messages. If you want to refund, you can use the same event bridge, same event bus. But just because it's a written process, it might invoke a different application here. So this is fan out, basically one message coming in, and it's fanning that messages out to multiple consumers, depending on what's needed. Now, in last year reInvent, there's something, within Step Function, a new feature was rolled out, which we call distributed map. And, there are many use cases to it. Now, for example, if you want to use distributed map, you can now iterate over millions of objects that are stored within S3 as part of Step Function. So let's say as a part of, let's say you have a lot of documents that need to be processed in a batch fashion or real time that are coming at a very fast pace. You can have Lambda function invoke Step Function in a distributed map state. So basically, every workflow over here is for a single item or a single object being processed. So if there are millions, you can literally have parallel executions which are processing every individual document in parallel over here. So that's where distributed map is very powerful. It can sustain up to 10,000 parallel invocations. Even within each execution, you can have process the documents in batches. So you are basically just increasing this number of documents that you are being processed. So that's where distributed map plays, a very important role. Think about intelligent document processing as well. If you want to do intelligent document processing on top of millions of documents, which comes in batches. You can achieve that using DMAP as well. All right. So this is all about AWS services, but we have something like EventBridge that integrates well with third-party partners as well. Salesforce, is a new partner which we just added to EventBridge. They can call EventBridge API directly for you, and Salesforce events are forwarded to EventBridge. You can do some real-time processing, and then also review some cases from Salesforce, and then after processing it, send it back to the Salesforce. So it basically also takes events from event sources from any third-party vendors, popular third-party vendors like Salesforce, Zendesk, PagerDuty, and so on. Well, so serverless is a very, very broad topic, and I was just scratching the surface. So if you want to dive deeper, I highly encourage reach out to your AWS account team. Check out our immersion days workshops. Some of them are openly available. Read about serverless well-architected review. Go to serverlessland.com as well. There are a lot of serverless patents that's been published. Very common patents. Some of them I've already covered here, which you can directly and easily use from there. We have AWS Skills Builder. We have ramp-up guides, where you can learn serverless. And there's also a serverless batch. So I highly encourage, once you have ramped up your knowledge, give this test, and AWS will officially give you, it's not a certification, but it's more like a knowledge badge for serverless. So you can achieve that as well. And with that, thank you so much for staying awake, for listening to me. I know I packed in a lot of it in it. If you have any more questions on serverless or want to dive deep, feel free to reach out to me in my email. It's my LinkedIn. Feel free to scan the code. It will take you to my LinkedIn profile if you want to stay in touch. Thank you so much.